Okay, boys and girls, young men and young women, this is a review, which means I'm not going to spend a whole lot of time on this video going over all the algebra. Okay, but I will show you the algebra, but there's going to be lots of magic where we start talking about a problem and then the answer is going to come up in the next second. So if I say pause the video and work it out, that means you should pause the video and work it out. Okay? So it says to use a sum and a difference formula. So hopefully you have your formula formula sheet with you. So you know to use a sum or a difference formula. Okay, I guess it doesn't really matter which one you use. So let's think about the first step. Our first step is to split 13 pi over 12 into two angles that add up to 13. Okay, so it really doesn't matter which ones you pick, but here we have something pi over 12 plus something else pi over 12. So the first step on all of these problems with sum and difference is to find two angles. So what two numbers add up to 13? 7 and 6 are great. Unfortunately, 7 pi over 12 doesn't reduce. So 6 and 7 is not going to be the ones that we use. Think about some other ones that do reduce, like maybe, I don't know, 9 and 4 or 10 and 3, right? 9 and 4 also work. So does 10 and 3 because these both reduce. Okay, 10 pi over 12 reduces to 5 pi over 6. 3 pi over 12 reduces to pi over 4. Both of those are unit circle angles that we can use. Okay, so once you identify your two angles, we're going to plug this into the formula. So make sure you have your formula somewhere for tan. And it looks like this. So after we plug it into the formula, now we're going to go to our unit circle. And from our unit circle, we're going to write down the tangent of 5 pi over 6. And we're going to write down the tangent value for pi over 4. Okay, so we're going to replace these things with their unit circle fractions. Okay, and that will look like this. Now it's a matter of algebraic simplification. Okay, so this is the hard part usually. So anything times 1, well, that's just anything, right? So we can get rid of that down there. Minus a minus, I can do that pretty easily. Minus a minus is a plus on the bottom. Okay. Now to do my addition, I have to add a fraction to a non-fraction. So I'm going to change my 1 to be a 3 over 3. Same thing in the denominator. I'm going to change my 1 to be a 3 over 3. That way I can actually do this fractional addition. And when I do it, I get negative root 3 plus 3, all divided by 3, right? That's my numerator now. All divided by positive 3 plus root 3 divided by 3 also. That's my denominator. Now we can notice that there is a 3 as both of our denominators. And when we multiply by the reciprocal, those 3's divide each other out. So what we're really looking for right now is the fraction negative root 3 plus 3 divided by 3 plus root 3. Okay, and here's where we get kind of tricky, because mathematics doesn't want you to have a radical in the denominator. So the way that we get rid of the radical is by multiplying by the conjugate. Now it's the conjugate of my denominator. I don't really care about my numerator, but the conjugate of my denominator is the exact same value, so it has a 3 and it has a root 3, but it's going to have a different sign. Our conjugate is going to be 3 minus root 3. We're going to multiply that by the top and by the bottom, okay? Because you have to multiply by the same thing, top and bottom, which is a 1. Okay, so we're multiplying by 3 minus root 3, because that's the conjugate of 3 plus root 3. Okay, so now follow the arrows as we multiply this out. I'm going to do negative root 3 times 3, and negative root 3 times negative root 3. And then I'm going to come back and do normal 3 times 3 and normal 3 times negative root 3. And now let's do the same thing on the bottom. Okay, we're going to multiply this 3 times both of my terms. Then I can multiply my root 3, positive root 3, by both of my terms. Okay, and this is what we get. So this is what your final answer looks like. Negative root 3 plus 2. Or, if you were so inclined, 2 minus root 3. That is also correct. All right, so now that we're done with the long one, let's get back to these easy ones. Okay, sine of 15. We need to think what two angles subtract to give you 15 degrees. Okay, any two angles will do, but the ones that come to my mind are 45 and 30. Okay, so we're splitting our 15 degrees into the sum, or in this case, the difference of two angles, subtracting these two angles. So now we go to the formula, which says the sine of 45 times the cosine of 30 minus the cosine at 45 times the sine at 30. Now let's go into our unit circle to replace these values. So the sine at 45 is root 2 over 2. The cosine at 30 is root 3 over 2. Minus the cosine of 45 is root 2 over 2 times the sine at 30, which is 1/2. So these values come from your unit circle. And now we do fractional multiplication, which looks like top times top and bottom times bottom. Okay, we do that to both of them. And our fraction reduces to root 6 over 4, because 2 times 3 is 6, minus root 2 over 4. And now, since both of these have the same denominators, I can combine my numerators into root 6 minus root 2. No, we cannot actually subtract those radicals. They are different radicals. They are not like terms. So our final answer is root 6 minus root 2 divided by 4. Okay, and our last one of these, the cosine at pi over 12. So let's split this into two angles that subtract to give you 1 over 12. Okay, so pick two numbers, any two numbers that subtract to give you 1, but also reduce. So maybe, I don't know, 3 pi over 12 minus 2 pi over 12, because 3 minus 2 is 1. Okay, 4 minus 3 would have also worked. 9 minus 8 would work, right? 5s and 7s would not work because they don't reduce. So this becomes the cosine at pi over 4 minus pi over 6, because 3 over 12 reduces to 1/4, and 2 over 12 reduces to 1/6. Okay, so now let's plug it into the formula, just like that. And now we're going to go into our unit circle and replace all of our trig with their respective fractions. The cosine at pi over 4 is root 2 over 2. The cosine at pi over 6 is 1/2. The sine at pi over 4 is root 2 over 2. The sine at pi over 6 is, well, no, that's 1/2. My brain. This one is root 3 over 2. That's the cosine at pi over 6. I apologize. And now to multiply, I get root 6 over 4 plus root 2 over 4, which combines to give me a root 6 plus root 2, all divided by 4 as my final answer for the cosine at pi over 12. Very good. So those are your unit circle ones. Because when we look at number 4, notice we have fractions. And when we have fractions, we need to draw our triangles. Okay, so fractions means we need to draw triangles. And it's important to draw them in the correct quadrant. Okay, so this is how we know what quadrant to draw them in. We're given this information about our angle. Okay, so if we're talking about between pi and 3 pi over 2. Okay, this is something that you need to know from your unit circle. That pi is directly to the left of your origin, and 3 pi over 2 is directly down on your origin. So this is a third quadrant triangle. And in the third quadrant, we need to know that the x and the y values are both negative. So when we draw our triangle in the third quadrant, right, this is your angle, this is triangle A, or alpha if you want to call it that. If the tangent is 8 over 15, well, that's the y value over the x value. So we have a y of 8 and an x value of 15. But in the third quadrant, both of these are negative. And the problem is not going to tell you that. You're going to have to know that because we're in the third quadrant, both of those values are negative. And when we do the Pythagorean theorem to find our missing side, we find that the hypotenuse is 17. Because we need to know all three sides in order to use our trig. Okay, so we have a third quadrant triangle where your x and your y values are negative, but your radius is not. Now the second one says my angle is between pi over 2 and pi. So pi over 2 is directly up from your origin, and pi is directly left. So this is a second quadrant triangle where we have a negative x value and a positive y value. So we draw our triangle in the second quadrant. This is triangle B, and I have a cosine of negative 24 over 25. So I have an x value of negative 24 and a hypotenuse of 25, because the hypotenuse is never negative. So if I have a negative fraction, one of the two parts is negative, either the top or the bottom. In this case, it's the top, negative 24. And when I do the Pythagorean theorem, I find a missing y value of 8. Positive 8, because in the second quadrant, y is positive. Because our problem says find the sine of the sum of these two angles. Okay, so using my triangles, I'm going to first write down the formula for sine of A plus B. Okay, write down the formula. Now we're going to replace. So we go to our A triangle and we write down the sine value. So the sine is the opposite, or the y, over your hypotenuse. The sine is negative 8 over 17. Okay, the cosine comes from B. So we go over to the B triangle, and the cosine is negative 24 over 25. Okay, and then we go back to the A triangle to write down the cosine fraction, which is negative 15 over 17. The adjacent side over the hypotenuse, or x over r. And then we go back to our B triangle to write down the sine ratio, which is 8 over 25. Okay, notice there's no longer any sines or cosines. The sine of the angle is that fraction, and the cosine of the angle is its fraction. Now we get out our calculator to do these ones. 8 times 24. 192. 17 times 25 is 425, right? A negative times a negative is a positive, which is why it's positive 192. Plus negative 15 times 8 is negative 120 over 425. They should always have the same denominators. If not, that means you did something amiss in there. So then 192 minus 120 is 72 over 425, and that is your answer. Okay, so this next problem has that same idea. We are drawing triangles to represent A and B. So triangle A is going to be in the third quadrant. Once again, third quadrant triangle. And triangle B is going to be in the second quadrant. So the same as we had before. Okay, so our triangles look like this. There we go. So using the Pythagorean theorem on triangle A, I know that this will be a negative 24. Because a 7, 24, 25 triangle, we just had that up above. So remember, in the third quadrant, the x value is going to be negative. The Pythagorean theorem won't tell you that. You have to know that. And on this one, oh my goodness, 2 root of 21. So we have 2 root 21 squared plus 21 squared equals c squared. Okay, so I need to distribute into both of these. So 4 times 21 is 84 plus 21 squared is 441. So adding these together is 525. Ooh, square rooting that. Oh my goodness, that's not perfect. But it is 25 times 21. So the hypotenuse is going to be 5 roots of 21. Okay, 5 root 21. Wonderful. Probably not, but let's see what happens. We need to find the cosine of A plus B. So we go to the formula. So now, let's get those fractions. Right, we're going to go to our triangle to write down these fractional ratios. The cosine from triangle A is negative 24 over 25. The cosine from B is negative 21 over 5 root 21. Minus the sine from A is negative 7 over 25. And the sine from B is 2 root 21 over 5 root 21. Okay, so don't worry, everything is going to work out okay, I think. Negative 24 times negative 21 is negative 504. Sorry, positive 504, because a negative times a negative is a positive. And then minus a minus here is also going to be a plus. This is going to be plus 14 root 21. And that's all divided by 25 times 5, which is 125 root 21. You know what? I think that will be okay for today. We don't need to simplify that. Multiplying it by root 21, let's let it be. So 504 plus 14 root 21 over 125 root 21. So maybe that was more algebraic simplification than we needed. So here's your first video. It's 18 and a half minutes. Okay, bye.